So, how many people here have a service that they think is too big? Yeah. How many people have services they think are too small? Yeah, one or two. Mostly the problem is services are too big. But how big should a microservice be? Everybody, when they first get faced with, like Saul said, when they first get faced with a microservice, the immediate question is, how big is micro? And there's a bunch of different answers. So some of these are funny, some of these are not so funny. Some of these you may have heard. The two pizzas. Everybody heard the two pizza story? The two pizza story is from Amazon. Jeff Bezos was in a meeting and people were saying, oh, we need more communication, we need better communication. He says, bullshit, communication's terrible. I don't want communication. I want teams small enough that you don't need communication. And he says, the biggest team that you should have is one you can feed with two pizzas. So if your team is too big, they can't communicate. Similarly, the idea is that the team for a microservice should be small enough that they can all talk to each other, so the team should be no bigger than two pizzas. As big as your head? You heard that one? The idea there is that a microservice should be something that you can comfortably keep in your sort of working memory. You don't have to keep looking things up. You don't have to talk to other people. It's something that's right there that you can remember, you can work with, that it's small enough that the conceptual size of it is big enough that you can keep in your head at all times. From the BDD world, people say that a microservice should be about the size of a bounded context. Of course, bounded contexts can be bigger or smaller. This one is one that I particularly like. You should be able to throw it away and rewrite it in 2 weeks. If you don't think you can rewrite your microservice in 2 weeks, it's probably too big. 12 people, which is the same as the two pizzas thing. I actually think that's too big. 6 people for 6 services, I've also heard. I think that's too small. That's too many services. Those services are too small. But those are two ends of the sort of spectrum that people have said. Everybody agrees that a microservice should do one thing and do it really well. So, of course, there's room for argument about what one thing is, but that's the basic idea. This one, as small as possible and no smaller, comes from Sam Newman's book. I don't know if you've heard that one. I like this one. It needs to be independently replaceable, deployable, or upgradable. That's sort of the stereo component idea of a microservice, is that you should be able to take your microservice, throw it away and replace it, and keep your system working. So you'll be able to, it's a unit that you can upgrade independently. It's also something that I can deploy independently without breaking anything else. So it doesn't have, you don't have a lot of coordination necessary when you're doing deployment. This one I also like, that it should be able to implement your microservices in heterogeneous technologies. So I should be able to take, if I have more than one microservice, I should be able to implement each one of them in a different technology, and you should not care. So if your microservices care what the other microservices are implemented in, you've probably got too tight a coupling, and you need to rethink your boundaries. And the one I like the least is the last one. Number of lines of code. Microservices are not measured by lines of code. But if you have to, and you don't, I would say they should be hundreds of lines of code, not tens, not thousands. So somewhere in the few hundred lines of code area. But like I said, that's the one I like the least. I hate that. So what makes a microservice too small? How do you know when the microservice you've got is too small? So the problem with microservices that are too small is that they don't end up being independent enough, and they don't end up being expressive enough. And so you end up with a whole cloud of things that all have to talk to each other, so you end up with integration issues. So if you notice that you're spending most of your time figuring out how services discover each other, how services talk to each other, what services do when they fail, then maybe you've got too many small services. That's also the inconvenient coupling, especially in deployment. If I can't deploy this service independently of all of the other services, then it may be too small. It may also be too big, but it may be too small. The last one, I think, is the most important one. A microservice is too small if it's mostly exposing its representation rather than some business logic. Microservices should represent business functionality as opposed to just the data inside an object. If what you've got is a thin layer of CRUD on top of an object and your RESTful interface is just CRUD, then you've got an anemic interface and your service is probably too small. And you're going to spend all of your time recreating your business logic in the front end and in the coordination rather than in the objects themselves. So if you've got small objects that all they are is a representation of a bunch of records and everything is either a get or a write of that record, those services are probably too small. Rewrite them with business logic, which brings me to my next slide. What do you do when your services are too small? So the first thing to think about is, in BDD terms, is maybe the boundaries of your bounded context are too small. So expand them outward, take all of your individual microservices and rethink about them as one giant aggregate and see if you can find better boundaries that way. So take them, combine them, maybe find things that are tightly coupled, that are hard to deploy independently, smash them together. If what you've got is a thin layer of CRUD on top of a representation, go back to the drawing board and think about what the business operations are that your microservices should be implementing. And implement those interfaces rather than your CRUD interfaces. And then finally, there's another symptom that's related to too small, that's not exactly the same as too small, is if you've got lots and lots and lots of services and you find yourself having to deal with way too many interfaces at the same time and different functions try to talk to the same half dozen services or so forth, is put in a kind of a pseudo service, an intermediate service. It's a service aggregator, an API service. Amazon does this. Amazon is famous for doing this. So what this service actually does is it orchestrates. It understands more about the logic of talking to multiple microservices, and it re-exposes a slightly different interface. So it doesn't actually do anything except orchestrate other services. And so that's one way of managing the complexity of way too many services, which is sometimes a symptom of services that are too small, but sometimes it's a symptom of a system that's just really big and really complicated. Sometimes your domain really is really big and really complicated. You can organize that by going up a level of abstraction and building yourself another service, which is an aggregation of the smaller services. Too big. This was the favorite part. Everybody has examples of services that are too big. So how do you know if the service is too big? Again, painful deployment. But the painful deployment here is less about coupling than it is about the fact that I can't deploy because somebody else depends on me and I'm going to break them if I deployed it. Or I depend on some service and I have to deploy at the same time that they do. Or I've got way too much code and actually building it takes a long time and testing it takes a long time and deploying it takes a long time. So that's one of the ways that you can tell that you've got a service that's too big, is that it's hard to deploy. It's not something that you can just deploy multiple times a day or multiple times a week. Similarly, it's hard to change. Again, because you've got lots of tight coupling inside this big thing, or it's trying to do too many things. When you change one thing, it's hard to figure out what all the other things are that might get affected. And it ends up taking you a long time to deploy this thing because it's not isolated, it's not simple. And this is a classic one from object-oriented design. Just why does my object depend on this thing, this interface that I've never heard of? Similarly, why does my service depend on this thing that I've never heard of? Why does my participant service depend on the mail server? Okay, so more ways to tell is you've got a service, and I don't know how you necessarily deploy your services, but let's assume for the moment that it's a RESTful service and it's got a bunch of endpoints. And you start off with just a few endpoints. You've got a GET, you've got a mutator, you've got something that accepts events. Gradually over time, you notice you get more and more endpoints. You've got specialized endpoints to do reporting, you've got specialized endpoints to do this, do that. And eventually, your simple microservice starts to end up with a dozen or 20 endpoints. At that point, then you should think about the fact that maybe the service has gotten too big. Similarly, even if you've only got one endpoint, if hiding underneath that is do command, and you've got 27 different commands that you can send to that endpoint, you don't really have only one endpoint anymore. You've still got 27 pieces of behavior underneath there. Maybe that's appropriate, but maybe you want to start thinking about if I can split this apart. This one is one of my favorite ones. If you've got a service that has multiple ways of persisting its data, you've probably got a service that's too big, and you've probably got an easy way of splitting it. So you split it based on representation. If you for some reason want to persist things in two different ways, maybe those two different things should be two different services. More. These are more organizational. This one is the two-pizza rule. If your team is too big, if they can't talk to each other, if not everyone knows what everyone else is working on, then maybe your service is too big and it's time to split it up. And I'll talk a little bit about Conways-Law and how that affects microservices later, but this is one of those smells. The other one that's a little bit subtle is, especially in an existing organization, you may discover that you've got multiple ways of integrating your services. So REST is very popular and is really good for talking to your front end. But for your services talking to each other, you may have XMPP, you may have 0MQ, you may integrate at a database, you may use some kind of RPC mechanism. If you're using in a single microservice more than 2 or 3 ways of integrating with other services, then something's wrong. And often what's wrong is that the service has actually gotten too big. You may want to split along integration mechanisms, or you may want to think, maybe I want to redesign the things that are integrating using this one mechanism to use a common mechanism, or combine them and refactor them into 2 separate services, 2 or more separate services. All right, so when you've got a service that's way too big, what do you do about it? Well, the obvious answer is you split it into multiple services. But how do you do that? I mean, obviously you thought that the service was split along reasonable boundaries when you first designed it. You didn't deliberately set out to make a service that was too big, but it grew to be too big. Now, what do you do to make it smaller now? So you refine the seams. Usually at this point, you have some feeling for actual fault lines inside the service. You have different problem domains. Maybe you've discovered the thing that used to be a single aggregate root actually has sub-aggregates within it. You can split those aggregates out into their own services. Maybe you've got one big service that's actually doing more than one business function, so it's doing both inventory and ordering. You split it across business lines. Like it says up there, you can look at coupling. So one of the things that you want in your services is for them to be loosely coupled and tightly and highly cohesive. So even if you've got a single service that's very cohesive, that all of the pieces nicely talk to each other, they may have unexpected external dependencies. Look at those dependencies and see whether or not you can split your service based on what it is that it depends on. These are fairly straightforward. Most of this actually has to do with scalability. So a lot of times you'll discover that your big service no longer scales very well. That in order to scale your service, you actually have to scale the infrastructure and make the service itself bigger. That's a smell. One of the big advantages of microservices is that they enable scaling through replication of the service. So you should be able to deploy multiple instances of your service. And if you can't, then it probably means you should split it up into pieces that are independently deployable and independently scalable. If some piece of your service needs to scale up by a factor of 10, and when you want to scale it up by a factor of 10, you discover that you're scaling other things up as well that don't need to scale, that's a smell that your service is too big. You probably want to split it apart into the independently scalable pieces. You can scale by functional decomposition, which will often be by business role. You can scale by data partitioning, so that's classic sharding, where you decide that different services will be responsible for different pieces of the data. And then duplication. You can just scale multiple copies of exactly the same service, all responsible for everything. That's better when it's read-only scaling. But you can, if you can't do that, then it probably means your service is too big and you need to decompose it into pieces where you can. Okay? And then, perhaps surprisingly, the same technique about taking multiple services and making it into what appears to be a single service works for breaking up a big service. So keep the same interface, but do it as an API service, and then break the back end up into multiple services that implement that API. That way your clients don't have to change, but you get all the benefits of breaking it up as a microservice. Now, the controversial one. I'm going to have some beer for this one. I've come to the Microservice Meetup to tell you when you should not use a microservice. When you should actually use a big monolith-based service, because there are times. Scott Shaw paid me to do this piece. No, he didn't. So sometimes the right answer is not to use a microservice. And I personally find this really hard to accept, but it's true. I mean, I love microservices. I've been doing loosely coupled distributed services for over 20 years. And I think they're the best thing ever. But, oops. So the advantages of a non-microservice are that the system can actually be simpler. Microservices are more complicated. There's a cost to pay in breaking things up into small communicating services. You also get, when you've got this big blob, you've got this consistency internally where the interfaces are in the same language, everybody's writing the same kinds of objects, you have a nice object model that you can share. Oh, I shouldn't touch the mic. And it's much easier to refactor a big service because refactoring across service boundaries in a microservice architecture is really hard. Moving this functionality from this service into the other service, oh my goodness, that's a pain in the butt. So, when you use a big service, technical reasons. If you've got a single homogeneous tech stack, then that's an opportunity to use a big service. If everything you do is in .NET, then this is the flip side of the idea that microservices can be heterogeneous, that you can implement each microservice in a different technology. If everything's going to be implemented in one technology anyway, you can take advantage of that to get some of the benefits of a single large service. This one drives me nuts. If you've already got this giant relational database on the back end, it's going to be really difficult to build a cloud of microservices that are all working off of that same relational database, because they're all going to have a shared back-end representation, which is anathema to microservices. Microservices should each have their own independent representation of their state. If you've got a big back-end database, you can't do that. Everybody's touching your representation. Everybody gets to see the innards of your representation. You don't get to change your representation to match whatever it is that your service needs. So if you've got a big existing relational database, it may make more sense to build a traditional 3-tier architecture or 2-tier architecture or whatever, a big service on top of it. This one is kind of complicated too. Microservice interfaces tend to be more granular, that the operations that you perform in a microservice tend to be simpler, there are fewer of them, and they're bigger chunks. If what you need is a bunch of fine-grained interactions between your APIs, if you've got complex interactions, if you need to pass state around, if you need it to be synchronous, it may make more sense to do it as a big traditional service. And finally, microservices work really well when they're asynchronous because you've got lots of them and you want to make it asynchronous. They don't work as well when it's synchronous. Certainly you can make synchronous microservices, it's not a problem. But if you've got synchronous services, it may make more sense to do a big service. This is the part I actually like better. There are organizational reasons to build a big service. The biggest one is when you're first starting out. You may still end up at microservices, but before you necessarily know your business boundaries, the bounded context, it may make sense to build it all as one big lump, get some experience with it, figure out what the operations are, figure out what you're actually going to be doing, pivot a couple times maybe, and then as you need to deploy and scale, as you get into the DevOps context, then break it up into microservices. So if you need to spike, if you're needing to build an MVP, it may make sense not to break it up into microservices right away, but to wait until you have a little bit more experience. Same thing with getting something out quickly. Microservices are more complicated, they're more complicated to deploy, they require really a little bit more tooling and infrastructure. So if you need to get something out tomorrow, I wouldn't do it as a cloud of microservices. This one makes me cry, but it's a reality. If what you've got are siloed teams, microservices work the best when you've got a small team responsible for the entire service. But if your organization is broken up into a UI group and a middleware group and a back-end group, it's much more difficult to build microservices. And again, this has to do with Conways-Law. You're going to end up building services that mirror your organization, And unless you have small autonomous teams, it's going to be very difficult to write small independent services. And finally, microservices really do require a certain amount of DevOps maturity. You need to be able to build a service, deploy it, getting into production, do that frequently, do that often, change the underlying technologies. Plus, microservices, in order to work well, need a certain amount of tooling around monitoring, being able to tell when things are broken, scalability. So you can't do microservices without a certain amount of DevOps maturity. So if your organization doesn't have it, it may make more sense to build a giant monolithic application. The other piece of that is that building one big war and then dumping it onto your app server, in a lot of ways, is simple. We know how to do that. So, all right, what's just right? So how do you build just right microservices? Two things to keep in mind, and this is not rocket science. This is not new. Solid and grasp still apply. Especially, make sure that your microservices has a single responsibility. Make sure it does one thing and does it well. And that it should be open for extension, but nobody gets to see inside it. So you can extend your microservices, but each one is its own little domain. High cohesion and low coupling, those are the essence of microservices. Each microservice should be highly cohesive, all of the operations should relate to each other, and each microservice should be loosely coupled to all of its neighbors. So the takeaway I'd like to leave you with is that the size of your microservice should be determined both by your business context and by your organizational context. So it's BDD and SOA crossed with Conways-Law. So small teams, business boundaries, give you the idea of what the size of your microservice should be. So that's it. Now, the fun part. Questions? So I've been doing real-world microservices now for the last 3 years. And so I've been building microservices long enough to see microservices get too big and have to split them up. And I've made enough mistakes where I've done the standard, let's just make CRUD over my database tables, and I'll call those microservices. And so I know why that doesn't work. We've made the mistake of drawing the bounded context in the wrong place and having to mush things all back together again into a single monolithic service and redivide it. So, I've got the scars. Question? Yeah?
So what's, in a typical business app, what's the first thing that you see people break off as a service? Like, if you're presented with a Rails app or a .NET app, what typically is the first piece that you see broken off?
User management. So it's pretty easy to model the users, the clients, whatever it is. So some way of modeling individuals and what things they want to do in the system. So that's the first thing I usually see. It's not necessarily right. It really depends on the business. So it's usually whatever the core noun is of your business, plus its associated business verbs. And so,
cool.
Yeah. Andy?
How to phrase this? Is being able to build a monolithic application a hurdle requirement? Sorry, is being able to build a monolithic application well a hurdle requirement to going microservices approach? Like if you demonstrably can't build monolithic applications well, should you even be considering it this way?
Well, if you can't build a monolithic application well, I think you're kind of doomed. So that's a really good question. I hadn't thought about that before. Could somebody who's not good at building monolithic applications successfully build a microservice-based application? No. No, you have to have a grounding in the fundamentals of solid and grasp, really, to be able to build microservices. And if you're not building good monolithic apps, you probably don't understand solid, for example. And so, yeah, you're probably going to run into trouble. You're almost certainly going to draw the boundaries in the wrong place because your domain modeling skills are probably not up to figuring out what the right seams are for your microservices. That said, I don't know how to cure that. I don't want to give people the advice of, you shouldn't be building microservices because you're not good enough. How do you get good enough? And so I'm not sure what to tell people about that, except maybe to practice, solid principles. Yeah.
Which is your preferred integration technology?
My preferred HTTP. Be of the internet, not behind the internet. HTTP plus REST. Use your HTTP verbs.
And queues?
Except for put. Don't use put. Sorry.
Yeah. Sorry. And queues. How do you feel about using queues as an integration technology? Like
Use
queue
which
or-
is I didn't hear.
Queues.
Queues. Oh, like 0MQ and Rapid.
Yeah.
I think they're fine for. I actually like those for inter-service communication. I also like REST for inter-service communication, but yeah, MQ is. I think that's probably my favorite integration technology for service-to-service communication. Yeah.
I'm just trying to understand the point about if you can or must use the same stack for all the services, then possibly don't do a microservice-based architecture, because we've been doing one. We had we were fortunate enough to be able to start from scratch with our system. Let's see, we've been at it for about a year, and we've been following the same tech stack, and we've been through the whole continuous delivery thing and all the rest of it, and it's now really coming to fruition because we've got stuff broken up in small bits. We can change them quickly. We've got the agility which we set out to get in the first place, basically. So that's great. But we're still sticking to the same tech stack. We're communicating over HTTP, because then that gives us the option of maybe going for Node for one of the services, or going functional for another service, or whatever we want to do. But we haven't done it yet. So I'm just trying to understand what the argument is behind that. Is it that you won't really reap the benefits unless you mix up the technologies, or not necessarily?
So I maybe should stand it on its head, which is that if you need heterogeneous technologies, you probably can't do a monolithic app. So having the ability to have a homogeneous tech stack makes it possible to have a large app. But also what you've described is sort of a step on the spectrum. It's not all or nothing. So deploying all of your microservices in the same technology may be perfectly fine if that technology is the best technology for every single microservice. But what microservices then lets you do is choose the right technology for that service, which may not always be the same. And unless you have microservices, you can't do that. So it gives you the freedom to use the best of breed technology.
That's the reason why we're basically so we're not boxing ourselves in.
Exactly. But I'm not going to believe you can actually do it until you write a service that isn't in the same tech stack.
No, we're going to do it.
Excellent.
Also, it wasn't worth this long journey and long.
Sure. But there are certainly lots of other benefits that you get even without that. But all of the benefits, you don't get all the benefits until you do it.
Would you be saying that when you say tech stack, you're not necessarily meaning language or platform, but also back-end database?
Representation, yeah. Persistent representation if you have one.
For example, it
Integration
might be all
technology.
.NET, that you might have a NoSQL on one microservice and a...
You haven't asked me what my favorite persistent representation is, but I think you might already know.
Tell me, Charles, what's
Yeah,
your favorite
it's flat
persistent-
files. I don't need a I haven't used a database in the last 3 projects. Not even a NoSQL database, mind you. Flat files. Yeah?
Sort of 2-part question. First of all, you see with all the sort of hype around microservices at the moment that people are sort of conflating the idea of Docker with microservices. So if you're doing Docker, therefore you're doing microservices. Do you see that happening?
I'm not sure what you mean when you say Docker.
Well, what I mean is like people maybe get exposed to microservices concepts by hearing about Docker.
Oh, Docker.
Yeah,
It's
Docker.
your accent I didn't understand.
Sorry.
I'm sorry. Docker. American.
Yeah. So therefore, they think because they're building these so-called lightweight containers that they're doing microservices. Do you see people thinking that way?
I haven't personally run into that. I haven't run into anyone who thinks just because I'm deploying using Docker that it's a microservice. I can deploy my giant Java-based
Exactly.
app server inside a Docker container just as easily as in an app server. So,
Yeah, and the second part of that was if people are sort of starting out implementing microservices, let's say greenfields, would you recommend they start with Docker?
no, I would recommend they start with a large monolithic service and split it apart.
Yeah, okay, because I sort of see people heading down that path, and obviously now they've got another thing to worry about, which is the complexity around the Docker.
And that's exactly why. And the reason I said that you should start with a large monolithic service is because it's simpler to get started with. And the same thing. So you don't have to do all of the inter-service communication when you've got one big service. Like you say, Docker just adds one more layer of complexity, one more layer of deployment and build and management, and where's my Docker repo going to be? How am I going to manage the versions of my containers? How are the containers going to talk to each other? Never mind the services talking to each other. How many services am I going to run on each host? Yada, yada, yada. Yeah, you don't need that on day one. What was, yeah?
About the size of the teams and doing microservices. I'm in a team of 5 developers. We have one giant monolith plus 2 microservices.
Plus 2 microservices.
Yes,
Okay.
he's starting splitting it out. But if they successfully split it out into 2 microservices, it's going to be 5 developers for 20 microservices. And you never get to a point of those numbers, 6 pizzas or 6. It's half a pizza and
That,
5 developers, 20 microservices.
knowing absolutely nothing about the situation you're in, I would predict one of 2 things. Either that's too many small services and you're going to be sad because you're going to have all the coordination problems and you're going to discover that you've got coupling between your services that you don't like. Or you need to hire more people and break into additional teams.
But I think those things are already implemented and working. They are making us sad because they are hard. The monolith is hard to deploy. We want to split
What-
it out.
What I would suggest, if you can, is first break it into 5 services and see how that goes. Don't break it into 20 to start with. If those 5 services are still too big, break them down again.
And then on the other side is we have the monolith. It is a big monolith. There's no argument about it. But I still always know out of these 5 people who is exactly doing what
Yeah.
part of it.
That's the benefit of 5-person teams, is you always know what each other are working. Yeah.
So that comes with a small team, not with
5? Yeah, 5 is a small team. Now, I'm a little bit worried, knowing, again, absolutely nothing about your project, is that I'm worried that you don't necessarily have your UI people, you don't necessarily have business people, you don't necessarily have, DevOps people, that it's just devs that you're talking about. It's 5 devs. And it's not really a cross-functional team. And so I like cross-functional teams for doing microservices. So you should know who your customers are so that you're working with them and that you're making sure that what you're building actually meets their needs. So unless your team is fully cross-functional, you're probably missing some of that context. So I would actually make your team a little bit bigger by adding in additional roles that you can now own the entire service. So for example, do you deploy your service to production, and when it's in production, do you get the calls when you need to support it?
It's with Dev and DevOps.
Yeah.
Ops.
Put the DevOps people in your team.
They don't like it.
Okay, put your team in the DevOps team. Either way, I don't care. Don't make that split. DevOps should not be a role. It should be a skill set within your team. At least that's our religion. And you should have to fix things when they break. Yeah?
Common data models, and what do you think about good, bad,
What's a data model?
common data model?
Yeah, what's a data model? Why does anyone outside of my service know anything at all about my data model? All you know about are my services. You don't get to see my data model. That's what I think of common data model. in the microservice world, shared data models is really bad because that instantly introduces coupling between your services. So publish an interface, live and die by that interface, let your customers own that interface, but you can change your data model whenever you want. No one cares about your data model, except you.
So at ThoughtWorks, this microservice that you've been building, is that part of the consulting thing where you go to a client and you're building?
Yeah, my clients are here.
Okay, so
That's why I have to be nice.
Try not to ask anything. So how are you finding times when you actually got to go to a client and you build microservice and throw it over the fence to them? How is that working as well as when someone's doing this in-house, or is there some trade-offs?
Thank goodness I've never had to do that. I am co-located with the client and we're delivering code together. We don't throw things over the fence.
I mean, like forever. So once it goes to the.
Oh no! Today was my last day. It's on them now.
Yeah. So do you find that harder when it's a microservice as opposed to monolithic?
No, not really. I mean, what do you guys think?
No way of export management, especially in tech.
As long as they're letting people know,
Yeah, like one of our drives was creating a system whereby, you know, it wouldn't matter if the team grows or if there's a staff turnover or whatever, because they can just come in and pick up a bit size and you can learn it in like a day or whatever. So it kind of.
So I feel like I may have given your question kind of, you know, brushed it off. So I'm not sure I understand exactly what you're asking here. So in a microservice architecture, in a consulting environment where the customer, the client, may not have been as involved with coming up with the microservices, may not be, you know, if we came up with a microservice and said, here's a microservice, good luck, is that worse than we come up with a monolith and hand them the monolith and say, good luck?
Or is it better?
Or is it better? I mean, the first answer is both of them are terrible, don't do that. But
It does happen though. So.
oh, of course it happens. I think the microservice version is a little bit better if you've done your job in terms of the contract tests and you've built small, loosely coupled pieces that satisfy a business need. It's easy to understand and explain what the business need is, that it satisfies, that the contract tests are a good explanation of what it does, what it's supposed to do. So I think it's a little bit better to do it as microservices. But to Andy's point, if they don't know how to do basic, you know, solid principles, it's going to be a disaster no matter what. More questions? One more question in. Oh, no, two more questions. One second.
You mentioned DevOps a couple of times. From a cultural point of view, if the DevOps concepts and philosophy didn't exist and didn't come to life at roughly the similar time in our history as microservices have, would the microservices movement have had to have invented them? In other words, to what degree is the fact that DevOps way of thinking is starting to take hold in the development community, and possibly the same thing for virtualization of infrastructure as well? To what degree have those two things helped the ability of microservices to get traction?
They certainly helped, but they're not a requirement. And this is one of the places where, having been in the industry for 4 years, is going to make a difference. I've been building loosely coupled distributed systems for 20 years. We didn't used to call them microservices, but they were small services that communicated using, you know, over-the-wire protocols. And they were a little bit more complicated back then. But you did that without any DevOps. We didn't have any DevOps. And so you built this entire giant complicated communicating system and deployed the whole thing. And it was horrible. And you know, when a piece broke, you didn't have good monitoring for all the dependencies. You did it anyway. Because the advantages of small, independent, loosely coupled interacting actors is so big that you do it anyway. And now DevOps has made it a lot easier. It made it much easier to deploy them independently and reduce dependencies, and made it possible to tell when a single component failed, so it makes it more debuggable. So things are better. But I think microservices would come about regardless, because they're such a good idea.
I was just wondering about this concept of just right, and it means that is it just right in perpetuity of that business problem, or
It's just right because that's how the
Or is it
Goldilocks
just right
story
at the
goes.
time?
It's not
Yeah,
just
it's-
right. No, don't read too much.
So
in.
that was
Thank
the
you.
first, that was the first sort of thing I was wondering about, because
No, that's just Goldilocks.
you know,
That's not.
industry changes, and you know, your business rules change and all that stuff. So my real question is really about growth. Like when you actually have to come back and upgrade that in response to something. Like, have you encountered a process where you're pretty much rebuilding the whole thing, or if you have to upgrade the representation? I guess using the flat file is very helpful with that, because you have to upgrade your representation. It's not that hard. Let's say you had to have new fields and new data in your
We do that all the time. We do it incrementally.
Right. So
Now you're going to get into another one of my religions, which is event sourcing. If you're using an event sourcing model, then adding incrementally new fields or whatever is just business as usual. That's what you do. You do it every day. Well, hopefully not every day, but you do it whenever you need to, and it's no big deal. And migrating schemas is things that other people do, because schemas are, you don't need schemas.
that was just what I was wondering in terms of like CD.
So, but I think you're raising a really important point, another point, which is when you have to, or when you want to re-architect a microservice for some reason, I think actually that's one of the big benefits of microservices, is because you've got this clean interface that's well-defined, presumably you've got good contract tests, you can re-implement it in any new technology you want, in 2 weeks, remember? And so, just take 2 weeks out and re-implement it in Scala or whatever. Even Haskell.
That would be one way.
Okay, 2 more questions and then I think we'll be
Just a
done.
quick one on event sourcing.
That's a different
in drawing
topic.
your boundaries
So-
between event, in drawing your boundaries for a service, for a microservice, between events or nouns, how do you think about that? Drawing the boundaries, or do you organize it by actors or nouns, or do you organize it by events or functions?
I'm going to sound a little glib here. I organize it by the business requirements. So it's whatever the business need of whatever the service is that I'm providing are. But getting past the glib answer, I don't think of the events as nouns. I think of the events more as verbs, or just as announcements of things that you need to deal with. And then the noun is usually whatever the aggregate root is. And so the aggregate is the noun. And so does that answer your question?
Yeah.
Okay.
What's your view on enterprise service bus? And I'm just sort of doing the answer, assuming it's bad, how do you move from the enterprise service bus, the old SOA mantra, to microservices? If it's bad.
I am so tempted to give a smart-ass answer to that, but I'll try and answer it seriously. If you've got an existing system with an enterprise service bus in it, it's going to be very difficult to start migrating that towards microservices. But you do it the same way you do with any. I would treat the whole thing as one big monolith, and then I would start pulling microservices out of it. They might not match the existing service boundaries, but I don't care, because as far as I'm concerned, this is all one giant ball of mud, and I'm going to build small services that come out of that. It's going to be very, very painful at first. So you'll pull out a microservice, and then you'll have this glue layer in between you and the rest of the world. And that glue layer is going to be filthy. It's going to be ugly. It's going to be nasty. It's going to be horrible. But that's the price you pay for taking this clean little piece out and having to maintain the existing semantics of the existing ball of mud. And you do that, and then a couple of times, and then the communication between the microservices that you pulled out is a lot cleaner. You still have this ugly glue layer, but eventually you can start killing off pieces of the ESV-backed system, and it starts to get smaller and it starts to get better. But it's really painful to start with, because writing that glue layer to your old services is just a bear.
So presumably the answer to the first question is EVs, it doesn't have any bad.
I don't have words strong enough to express how much I hate ESBs. Die in a fire is just too weak. Really. Okay, that's it.
Okay.